7. Off we start. So this unit, as you will pretty much know it, it's a financial unit. Um, I don't know whose idea it is to add a finance unit, but it was a pretty good idea actually, in my opinion. So a lot of people they prioritize in getting engineering programs at top universities, so they don't take a finance class or a business class. But when you come into real life and you were like, oh, well, it's so necessary being financially literate. And I guess a lot of math teachers, they really take this part very serious and they talk about a whole lot of things. But as much as I like economics, I can't really pull out the inflation curves, the Phillips curves, the aggregate demand and supply graph on you. I cannot do that. But I could teach you some math part of finance. So let's go ahead and start the investigation of simple interest. Now, simple interest really isn't used anywhere in life because, first of all, it's really not a great way to accumulate wealth. So, simple interest, as you already know, it's basically you have $1,000 and it's gonna accumulate some sort of interest. So, for example, let's say 10% interest, so I'm gonna gain $100, let's say every month. So, I'm gonna store this at whatever bank, and it's gonna give me 10% interest. So, I'm getting $100, another $100 next month, another $100 for another month. So, every single month is always going to compound with your original principal. So if I put in $1,000 every month, I'm just gonna get 100. But compound interest, on the other hand, is gonna be $1,000 at the start, and then for the first month, I'm gonna get $100, and then next month, instead of using this $1,000 to compound, I'm actually using 1,100, which is 1,100. So I'm actually getting more. So you will find out that compound interest is so much better as a wealth accumulator than simple interest, and as well for banks, it is so much easier for them to collect more interest and earn more money with compound interest to the point where that simple interest is rarely found anywhere in life. Anyways, let's go ahead and start the class. The money you invest or borrow is called the capital. The interest rate is the percent of principal that is earned or paid as interest. The sum of the principal and the interest is called the amount. Suppose you invest $1,000 that earns simple interest at a rate of 5% per annum. Annum means a year. How much interest would you earn in the first year? What would you have after 1 year? And since simple interest is being calculated, interest first year is not reinvested. How much interest would you earn in your second year? So these are some questions, very simple. You could try them on your own. I mean, it's usually necessary, but it's very easy, in my opinion. Just spin this. Da-da-da-da. Okay, there. All right, let's go ahead and get to answering these questions. Get a small text box. So, A. How much interest would I earn in the first year? Well, I'm only earning 5%, so I will basically pull out my calculator, or if it's not a nice number, but in this case, it's 1,000. It's a great number, so I'll do that. Whatever number I have times 0.05, I'm gonna go ahead and get $50 in this case. $50 in the first year. B. Enlarge this. What amount would you have after 1 year? So $1,000 plus 50, so 1,050. After 1 year. See, since simple interest is being calculated or interest from the first year is not reinvested, so how much interest would I earn from the second year? Well, it's going to be the same because the interest I earn every year is going to be constant. D, how much interest would you have altogether? So I will have 50 plus 50 equals to $100 accumulated from both year. What amount would you have after 2 years? So it's going to go ahead and be, sorry, it's going to go ahead and be 1,000 plus 100 equals 10. Therefore, at the end of 2 years, I would have $1,100. Okay, so complete a table like this for the following 10 years for 1,000 invested, simple interest at the rate of 5% per annum. Use your answers from the question 1. Da da da. So this one is really easy. You could do that on your own, but I really think it's a waste of time, so I didn't do it. Plot the points in question 2, and I didn't do it as well. And then now let's consider the values in the table. So what kind of sequence do we notice? So this is where we get interesting, because as we just left off a sequence unit, it's pretty interesting. So we could see 1000. So usually for our amount, it's going to be 1050, 1100, 1150, 1200. So it's gonna always be a near arithmetic sequence, and we're gonna start on 1000 or 1050, whatever you start. So this is a near arithmetic sequence. The first term of the sequence could either be 1000 or 1050. What is the difference between the consecutive terms? So it is 50. This term is called a common difference. However, in our case, it's actually called the interest every year. Now, let's get to the fun part. We can actually go ahead and write a formula. All right, so let's write a formula. So what's our principal? Our principal is going to be 1000 plus 50x. Right? This is our formula. We could use it to derive whatever, or you could, in terms of n, you could write 50n, whatever you want. Right? So now we're actually getting to the function kind of thing of math, and it's pretty interesting. So let's go ahead and do this. 5a, substitute 1, 2, 3, 4, 5, 6, 7 away all the way to 10 for into my formula from part D of question to find this. So you should have already done this, and it should have been the same with this, so I'm not going to do it. And graphing it, it's interesting because you're going to get a linear graph. So not really hard. Use the table. Let P be the principal in dollars, R be the interest rate expressed as a decimal, and 0 be the time in years. Write an expression finding an interest. So I'm gonna go ahead and introduce you to the simple interest formula. It's gonna be amount at time t. It's gonna go ahead and equal to principal multiplied by 1 plus 0.05 in our case. Sorry, not this. P plus I would say P times 0.05 at t. Okay, so this is basically our formula that we have. So our principal plus the time that we have gone through, and the principal times 0.05. Or actually, no, I'll just write I here. So we have interest rate, so 0.05. So, and we have our principal. So this is how much interest we're earning per year, plus the time that has already gone by, plus our initial amount, and we're going to be able to get any amount in, any point in time. Let I be the interest in dollars. Oh my god. I. Here, there you go. Let's CB dollars. Okay, I did A at T. Substitute I in formula. Okay, so these are pretty much the same thing. And 7 setup. Okay, input 1, 2, 3, 4, 5. Yeah, so we should still get the same answer from this arithmetic sequence. In fact, this question is just showing you that we could get the same answer from different methods. So for the first one, we use the sequence and series method. However, for the second one, we use more of a mathematical formula method, which is pretty interesting. Consider my graphs. What is the shape of my graphs? So my shape is going to be a linear line, straight. The y-intercept of my graph is also going to be my principal amount, which is 1000. And what does each y-intercept represent for the? Okay, so there is unfortunately only one y-intercept. What is the slope of each graph? The slope would be the amount of interest that we earn every year. So for example, in our case, we have 50. The slope would also mean the slope is basically the rate of increase per year. So basically, if I have a slope of 50, I would increase by 50 per year. The y-intercept to calculate this equation, let's go ahead and do that. No, why is my text box not forming? Wow, what is going on? Okay, let me just get another text box. Text box here. Da 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 da. 8. What is this? 8. 8. F. So y equals to 50x plus 1000. Right? We're done. Graph it. You don't need to graph this. I really don't think you should. It's a waste of your time. Are the graph linear or non-linear? Linear. Linear because we have a constant slope. B. Why is it reasonable to join the points? Because technically our money is still accumulating between time as we are not directly earning. So we're not we're not how would I say this? We're not increasing $50 right at the end of the year, but rather accumulating throughout the year. Okay. Use one graph to estimate the amount of time from 1 to 10 years. So you could use your graph earlier if you did it out. I would recommend you just do decimals. TN, use this, plug into your formulas, whatever. Suppose you have and you earn this. So the appearance of this graph will be the same. You will have the same y-intercept as we did earlier, except you will have a steeper slope, as you will be earning more money each year now. So 1,000 times 0.0675, it's gonna go ahead and get you $67.5, and so we have a steeper slope. What amount would I have after a year? So $1,067.5, and 2 years you just add another 67.5, and blah blah blah. The sequence here is also arithmetic. The first term is 1,000, and the common difference for each term following is 67.5. The formula for Tn, you could write that yourself, and the equation will go ahead and be 10f 10 sorry g. It's gonna go ahead and be y equals to 67.5 x plus 1,000. That is your graph, and my graph compared to part A, which is my prediction, should be the same thing because I already know. So use your results to describe the relationship between simple interest, arithmetic sequence, and linear growth. Now this is where we piece everything together. Simple interest is equal to arithmetic sequences is equal to linear growth. This is because we are always increasing by a constant slope, and the graph is always a constant line. It's always a straight line. And we're done. This is the investigation of simple interests. Very simple, clearly. Simple interest, pretty simple. Next class, we're going to go ahead and get into compound interest. And then later, we're going to get into annuities. And I guess I have to talk a little bit of probabilities in stocks and rate of investment, blah, 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 stuff like that, economic stuff. But yeah, this is pretty much it for now.